The energy demand is expected to rise 45% by the year 2030, and at the same time we have a target of reducing our CO2 emission by 80% before 2050. But how can we achieve this target? That's what we're gonna present in this footage.
We will present our vision of how to reduce CO2 emission in power stations that use natural gas, like the one behind me. The University of Aberdeen campus heating system provides 1.6 megawatts of electricity and 1.7 megawatts of heat.
To tackle the issue, we need to focus on two of its aspects: carbon capture and storage, often referred as CCS. Let's start with the carbon capture.
There are three known and practiced CO2 capturing processes. We'll go through pros and cons to choose the most promising one. The post-combustion process is a technology that is already known and used in the food industry. However, the biggest issue with this process is that it cannot be used in large-scale projects because of the very large size of absorber columns. In addition, we cannot prevent the slip of very toxic ammonia. The pre-combustion process is a very new technology. The hydrogen gas turbines are not fully developed yet, and the hydrogen burning process is way too expensive. The idea of producing additional power by burning out the hydrogen is a great advantage, but there are low chances for this process to be evolved by the year of 2020. The oxy-fuel combustion process is very similar to the post-combustion, with the main difference in carrying out the combustion with pure oxygen instead of air. This results in a very simple separation of CO2 and even 100% of CO2 capture. The only problem is with the high cost of producing the oxygen, but we believe that this problem can be solved using chemical looping. Our team believes the most promising capturing process is done by the oxy-fuel combustion because of the largest possible percentage of CO2 capture as well as low environmental impact.
Chemical looping combustion involves the use of metal oxide as an oxygen carrier, which transfers oxygen from the combustion air to the fuel under atmospheric or pressurized conditions. The basic advantage is emission of a separation process and the direct separation of CO2. The CLC principle is based on two separate reactions: reduction of metal oxide by the use of fuel and air oxidation of the resulting metal.
We have already decided which method of CO2 capturing to use. But what about the storage? The solution is just behind me.
The North Sea. Let's present some of its major features. It's about 900 kilometers long and 580 kilometers wide. Its average depth is 90 meters, although it gets as deep as 700 meters. Salinity is 35 grams per liter. But what really makes subsea storage better than other alternatives? First of all, its volume. It's estimated that the rock formations underneath the seabed can hold up to 150 billion tons of CO2, which coal mines wouldn't be able to accommodate. Also, due to extensive geological research, the North Sea is already very well understood. Safety. It should always be a priority. In case of coal mines, there is a possibility that a leak of CO2 can occur, although the likelihood of it happening within a subsea storage is significantly smaller. It's all due to the fact that low temperatures and high pressures can turn the carbon gas into a liquid, which is denser than the water around it. Although the technology is still in the initial stage of development, it looks promising. For the last 19 years, the Norwegian offshore gas field called Sleipner has been successful in injecting 1 million tons of CO2 per year without any leakage. In New Jersey, US, construction of a new coal power plant is underway. What makes it really special is the fact that it will become the first in the world to pump CO2 100 kilometers offshore.
Apart of technological advantage, subsea storage in the North Sea can create up to 200,000 well-paid jobs.
Oh yeah, that's it.
As you have seen, we promote technologies that we believe are the best for the environment.
When making the final decision, we also kept in mind that it has to be feasible by the year 2020.
It was our energy for the planet.